Hello guys, welcome to online key fact in physics. In our last class we looked at one basic problem in collision, and today we have another problem in collision, and this is a past question just like the last one. This is gotten from WAEC 2020. So this question says two bodies A and B of mass 0.2 kilogram and 0.5 kilogram respectively are placed in a narrow path as illustrated below. This is illustration. Two bodies A and B placed in a narrow path. Given, the question continues to say, given that A and B are traveling at 5.0 meter per second and 3.0 meter per second respectively, under a head-on collision, that is, when a head-on collision is happening, when this and this are traveling with this velocity and this velocity, so under a head-on collision, so that there is a change in the total mechanical energy. There is a change in the total mechanical energy. Calculate the velocity with which they move after collision. So it's asking with which velocity did these two bodies move after collision. And the question II is saying, state the condition under which A and B will collide when both are in motion. So let's look at the question. These are two bodies A and B in a narrow tube. So we know solution. So this is body A and body B. And body B, so they are moving with a velocity. They have a mass 0.2 and 0.5. So body A has a mass of 0.2 and body B has a mass of 0.5 kilogram, 0.2 kilogram, 0.5 kilogram, and body A is moving with a velocity of 5.0 meter per second, velocity of 5.0 meter per second, and body B is moving with a velocity of 3.0 meter per second, a velocity of 3.0 meter per second, under a head-on collision. So there's a head-on collision. So we are assuming that body A is moving towards body B, and there's a head-on collision. Head-on collision. So we are also assuming that B is moving in this direction, since the direction is not stated. So we are assuming that the two are moving in the same direction. So if there's a head-on collision such that there is a change in the total mechanical energy, it simply means that momentum is not conserved. Sorry, it simply means that kinetic energy is not conserved. Now remember when we did the types of collision, we said that momentum and kinetic energy is conserved in the first kind of collision, which is the elastic collision. While in the inelastic collision, momentum is conserved and kinetic energy is not conserved. What that simply means is that there's a reduction in energy. They are moving with a velocity, and once they collided, there's a reduction in the total kinetic energy. It means that the energy before collision is no longer equal to the energy after collision. So energy is not conserved. So assuming there's a total change in kinetic energy. So this simply means that this kind of collision is actually the inelastic collision, which means that these two bodies will move with a common velocity after the collision. So this is before collision. So it means after collision, although it wasn't stated to us whether they stick together and move with a common velocity, it wasn't stated. But we already know that it's an inelastic collision. So it's either they stick together or they are moving separately but at a common velocity with the same velocity. So we are going to assume that they stick together. So we say stick together and they are moving with a common velocity v, which is same body 0.2 kilogram and the same body 0.5 kilogram. And we know that our formula for inelastic collision is that M1 U1 plus M2 U2 is equal to M1 plus M2 close brackets V. So our formula remains, I'm bringing this formula up, M1 U1 plus M2 U2 is equal to M1 plus M2 bracket V. So let's take the values. Let's take our values. I have that M1 is 0.2, M1 is 0.2, multiplied by U1, U1 is 0.5, U1 is 0.5, plus M2 is 0. M2 is U1 is 5.0 rather, then M2 is 0.5, multiplied by U2 is 3.0 is equal to M1 5.0 plus M2 M1 0.2, sorry, and M2 0.5 multiplied by V. So 0.2 multiplied by 5 should be 1 plus 0.5 multiplied by 3 should be 1.5 is equal to 0.2 plus 0.5 is 0.7 multiplied by V is 0.7 V. 0.7 V. So this I'm going to have 2.5 is equal to 0.7 V. So I'm going to make V the solution formula by simply dividing both sides by 0.7. So 0.7, 0.7 will cancel out. I'm going to have that V, of course this is going to be 3.57. 3.57. So what I'll have is that V is equal to 3.57 meter per second, which can be written as approximately 4 meters per second. So the velocity with which the two bodies M1 and M2 will move is going to be 4 meters per second. So when they collide and move together, the total kinetic energy will definitely decrease. So this is the velocity with which they move. So the question II is saying, state the condition under which A and B will collide. The condition under which the two bodies will collide will definitely be that the velocity of the body A, this is what we have in the narrow part. So the condition under which this body and this body will collide is simply that the velocity of A must be greater than the velocity of B. That is simply the condition under which they collide. And if you look at the question, you will find out that the velocity of A is actually indeed greater than the velocity of B. So the velocity of A is 5 meters per second, and the velocity of B, body B, is 3 meters per second. So the condition under which collision will occur will be that the speed of A is greater than the speed of B. So I believe we've been able to get one or two from this. In our next video, we'll also look at another question that may come in a different dimension. And then we'll look at also Newton's third law of motion and related problems. Thank you for watching. See you in our next video.